Good morning all of you, and let's see this problem. Let n be a positive integer. Points A, B, C are selected from the unit n-dimensional hypercube given by this set. Tn is the maximum area of triangle ABC for n belongs to natural number. We need to find T2 and T3 values. Later I'll generalize this expression for Tn as well. So this again, as usual, it's better to appreciate the problem. So how this set is defined? This set is the set of n tuplets of real numbers, such that all those real numbers is lying between 0 to 1, right? So let's restate the problem for n equal to 2. And that's really cool because for n equal to 2, our given hypercube will be 2-dimensional and it will become square because x1 and x2 has to from 0 to 1. Right, so let's draw this hypercube in 2D. It represents all the point in or inside the boundary, and now we need to select any 3 points. Let's say A, B, C, and we have to maximize the area of this triangle. Now for 2D case is very obvious to maximize because let's say if I fix the given base, since I know area of triangle is half into base, so here AC into height, let's say H. So for a given base, I can monotonically keep on increasing the height here. So I can lift it and put it maximum up to the border line. So corresponding to base AC, I'll get that height. And clearly I can again monotonically keep on increasing the base here. So the maximum possible value of AC will be root 2, right? Because that will be the diagonal of the square. So we can analyze this under two situations. Let's take a situation when the base is maximum. Under this case, the height maximum will be the height from the vertex, and this maximum height is 1 by root 2, which can easily be done by, because this is 45 degree and this length is 1, so by trigo this is 1 root 2, hence area in this case is half into root 2 into 1 by root 2, which gives half. But now claim is still not clear whether this is the maximum area. So let's say if I take some other configuration with base 1, and here again if I take any point on this border line, this area will be half into base into height, which is still half. So here my claim is the maximum area that I'll get in the case of 2 dimension is half, and I can't achieve anything greater than. And that feels obvious here over here because with this base 1 you don't have any other choice apart from going to the maximum height. And even if you take the base 2 maximum, as in this case the height maximum will be 1 by root 2. Now for any other possibilities, let's say if someone takes any other base, definitely is lesser than that, so area is going to be less. If you go even this side, right, so base is decreasing, height is increasing. We know the minimum area is 0 at this point. Similarly the area is 0 here, so somewhere it's becoming maximum, which is exactly the half-fold symmetry. Still after some time I'll give you a regress proof of this. So there are two ways of doing. Either I'll give regress proof of T2, or we can start with T3 calculation and give regress proof there. Okay, so I feel it's better if I can show you the field for 2 dimensions only, and then we'll directly generalize for n dimensions and first for 3 dimensions as well. So again, so now let's take a general point ABC. So how to prove my claim here? Because still now it's not mathematically regress that half will be achieved. I have shown half is achieved, but whether half is the maximum point is not being proved still. So what I'll do here, given any point A and B, I know the coordinate of point A, let's say XA and YA coordinate, is definitely lying from 0, 1 because you are within the square. And so is for B and C, right? For all those points, they have this relation. So let's say angle between AB vector and AC vector. Now I'll select AB vector always in the increasing x coordinate. So what I'm doing is XB minus XA is positive, and similarly YB minus YA is positive. And if I create again in the increasing direction, so let's say if I consider vector CA, so for CA vector again I can tell xa minus xc is a negative, but ya minus yc is positive. Okay, so in that sense, if I'll ask you to find the area of this triangle, it's nothing but half into AB cross AC magnitude, right? It's area of triangle in this case, or half into AB cross CA, whatever direction you give it, doesn't matter. And let's say the angle between AB and AC is theta, so it's half AB AC into sine theta over here. So how can we write the value of theta in terms of that? So let's say the component of AV vector. So AV vector I'm defining as coordinate of B minus coordinate of A. And let's say that component I'm writing as B1 comma B2. So it's basically AV vector is B1I plus B2J into D. And AC vector I'm defining as, let's say, C1I plus C2J. So now I can write cos theta as dot product of those two vectors. So B1 C1 plus B2 C2. I'm taking the acute angle. So outward direction sense by root over B1 square plus B2 square into C1 square plus C2 square. And if I'll simply plug this cos theta value over here, so I'll get half ABAC. Sin theta is 1 minus B1 C1 plus B2 C2 by AB times AC whole square, right? So I'll get half times root over AB square into AC square minus B1 C1 plus B2 C2 whole square. Exactly same work can be done even for a dimensional vector. So for 3D we'll have just a new component B3 and C3. So half into AB square is B1 square plus B2 square and AC square is C1 square plus C2 square minus B1 C1 plus B2 C2. Now we know in order to maximize this triangle, clearly these vertices must be on the corner points, because if it is not in the corner point, I'll always have opportunity to move the height up. Similarly, I'll always have the opportunity to move the base and to increase the base, right? So hence, now instead of looking for the continuous real values, I can look for B1, B2 and C1, C2 only from the set of 0 and 1. Why I'm doing this? Because anyway it is the component. So magnitude wise, this component, okay, from the smoothness, I can tell we like the maximum constant in which you can go in the leftward or upward direction will be 0 1. Now some of you might tell, like, why not it is 0 1 and minus 1, because even the difference of this vector can give negative answer. Let's say if I have A and C over here and it is within this square, so what if we consider C minus A? So that will give, like I'm running by 1 unit, but you are going down by 1, let's say minus half, something like this, half comma minus. That is already taken care of because simultaneously it will not be achieved. So you can easily see, like if I take B1 B1 and C1 C2 to be 0 comma 1, so now based on this input I need to discrete input, I need to maximize this value. And to be most greedy, in fact, I'll maximize this and minimize this at the same time. Now sum of square will be invised when it will be 0. So the way to produce 0 is they must have opposite parity. So let's say if I take B1 as 1, so 1 square plus 1 square, and if I take this as 1 square plus 1 square all as 1, then it will not give me non-zero answer. So it's 0, so delta will become 0, so half times root over this, right? That's clearly not the maximum value. So let's try for more. Half times 1 square plus 1 square, possibly 1 square plus 0 square, and minus 1 into 1, the dot product is going to 1 square. So that is again 2 minus 1, so it's half into 1. So we achieved a value of half, but still I can't claim that's maximum, because let's minimize this and maximize this. So is it possible? Simultaneously not possible, because if we'll make a maximum value of this as 4, then at that time this will also become 4. So little bit we have to sacrifice our grid, and we'll have half times, Let's give another try. uh, if I'll take 1 square plus 1 square, and let's say 1 square plus 0 square, and here 0 square plus 1 square. So now it's 1 into 0 and plus 0 into 1, so that goes. So we have half into root over 2, and that will give you 1 by root 2. So clearly it's lesser. So by playing with these values, now I am convinced that half is the maximum answer that will get out from it. So the maximum value of this will be half, corresponding to T2. Now similarly, you can play with n equals to 3. So now we are in a cube. So in the cube world with vertices coming from the set 0, 1, cross 0, 1, cross 0, 1. The reason being, again, like given any triangle in this cube, there is always an opportunity to increase the height for a given base, and for a given height there is always an opportunity to enhance the base. So again, that gives me, like, instead of taking the points from a continuous interval, I'll take the extreme interval. So that's the motivation for discretizing the problem at the first go. Once I've discretized, and now I can use the same idea. So area of triangle is this case. If I consider this as a vector, let's say AB and AC. So instead of 3 vertices assigning the real numbers, 9 unknowns, I'll assign just 6 unknowns. Because effectively B minus A will give 3 real numbers as a vector. So we'll have half times A1 square, or in that language it's B1 square plus B2 square plus B3 square, times C1 square plus C2 square plus C3 square, minus B1 C1 plus B2 C2 plus B3 C3. Now again, let's play with the values. So all these BICIs belongs to 0 and 1, because simultaneously they can't achieve the configuration of -1 in this if I are going down. So without any loss of the nullity, I can take this. The explanation of this part is already mentioned above, so you can also argue why it has to be the case. And now again, let's play. So let's minimize this value, this whole square, and maximize this. So again, to be on more greedy side, I'll take 1 square plus 1 square plus 1 square, and let's say 0 square plus 1 square plus 0 square, so as to kill this as maximum. And unfortunately 1 is left, so we have this time half into root 2, so it's root 2 by 2. Can we increase it? Probably this is possible, because I can take maybe delta as 1 square plus 1 square plus 1 square. And what if I take exactly 1 and 2 0? It will not work, because it's exactly same thing, right? So here I have to play the game, and the game is let's make it 0. So I want 1 0 plus 0 1 and plus some 0 1 kind of a structure. That can be given by 1 square plus maybe 0 square plus 0 square times 1 square plus 0 square plus 1 square plus 1 square. So we have here 2 minus 0. Well, that's still not working. That's still giving root 2 by 2. Let's try one more last time. So what I'll have 1 square plus 1 square plus 0 square and 0 square plus 0 square plus 1 square. Or let's say 0 square plus 1 square plus 1 square. Well, so that will give minus 1 into 0 plus 1 into 1 plus 0 into 1 whole square. So it's half times root over 2 into 2, 4 minus 1. Oh, well, so we have increased the value. So now it can be shown like you can't further increase, because you can play with some more values, and because if you want to increase this, we'll convert 1 0 to 1, and then this will become non-zero, so it will balance. Hence, from this analysis, what I've shown is the maximum possible value of this is root 3 by 2. So for the cubic case, the maximum possible area of a triangle that will get out of a cube will be root 3 by 2. Now let me show its existence, because you can backtrack and check the points x1 x2 which gives birth to this vector, because this vector was 1 1 0 and we have another vector which is 0 1 1. And it's not hard to see because for a cubic they are the points on the diagonal plane. So actually this is a case of equilateral triangle, because if I take, let's say, on this face, one face is one diagonal, and we have this another face over here, right? So these three are face diagonals, and if I'll take this face diagonal, so this guy is root 2 root 2 root 2. So basically it's correspond to the sides of equilateral triangle, having root 2 as a side, so we'll give root 3 by 2 into 2a square. So root 3 by 4 into a square is the area of equilateral triangle, and this area is going to be root 3 by 2. So here I have proved mathematically also the maximum area will be root 3 by 2, and that will correspond into the equilateral triangle case over here. So I hope you have enjoyed the problem and see how beautifully the problem was created based on a commonsensical aspect of discretization. So from the continuous window we first discretize this, and then from the discrete window by playing with some numbers and by operating with n iteration, we have shown this is going to be the consequence for 2 and 3. Now it's very interesting to note that for Tn I have tried basic coding, and which gave, like basic iteration gives 1 by 2 times. So the area for n will be, the maximum value of area will be an equals, so max n will be half times the square root of n square by 3 greatest integer. So if you'll keep on playing with this, the final answer for n hypercube max n is half times the square root of n square by 3 greatest integer. Okay, so this will be the final answer for this problem in a generalized version, and that feels pretty cool. You can feel by putting n equals 2. So for a square case is 4 by 3, which is 1, so answer is half, and for cube it's 9 by 3, so it's root 3 by 2. And if I ask you, like, if the maximum possible area of triangle is a positive integer, then what will be the minimum value of n? And once you generalize this, is possible to find this. So if I tell like this maximum positive value is a positive integer z plus, then find the minimum value of n. That can be another question, not at possibly JE but semi ISI. Once you generalize this pattern, then that's possible, because the minimum value that you'll get is corresponding to n equal to 7, because this we can play actually. You can check for n equal to 7. For the first time we'll get it 49 by 3. 49 by 3 will give 16 point something, so it will correspond to half into root 16, which is 4, so maximum value will be 2. So the area will be 2, corresponding to a triangle in 7 dimensions. Okay, and in 7 dimensions also you can define the norm or the length of the vectors as sigma bi square and sigma ci square. Just I have to run from 1 to 7 or 1 to 10 for the same region. So what's beautiful is you see how mathematician is going beyond the dimension aspect of perception, and we are not restricting ourselves in the 3-dimensional world just because we can perceive only 3 dimensions. Okay, so I hope you are enjoying the lecture, and please do like and subscribe.